The distributive property of multiplication over addition is expressed like so. And this is a property that we're pretty familiar with. For example, we know that 5 times 2 plus 7 should equal 5 times 2 plus 5 times 7. And we can verify that. 2 plus 7 is 9. And 10. Now 5 times 2 and 5 times 7 is 10 plus 35. And we see that both ways we end up with 45. Now that doesn't verify the whole property, but we are familiar with the fact that that property does work. Addition does not distribute over multiplication. And a lot of things that you want to feel like are distributive are not, and you get a chance to check that in your text. That's fairly easy to see. Let's just zoom in and do one short example. For example, it's not true, if we use the same numbers we did before, that 5 plus 2 times 7 equals 5 plus 2 times 5 plus 7. 5 plus 2 times 7 is 5 plus 14. 5 plus 2 is 7. 5 plus 7 is 12. We get 19 here, we get 84 here. In general, we expect a bigger result over here than we do over here. Okay, that would be ridiculous. We see clearly that this sort of thing doesn't happen, whereas it does work if we use multiplication distributing over addition. Now here's an example of two operations, and again I guess we best zoom back a little bit. Okay, here are two operations, star and dot. And we want to see whether the star operation is distributive over the dot operation. In order to check that out, let's first evaluate B dot C. B dot C is B. So that we replace B dot C with B, and now we have A star B. Now is that equal to A star B dot A star C? Well, A star B is A, and A star C is A. Okay? Now what's A star B? A star B is A. A dot A. Well, A dot A is, well, how about that? It's A. So that seems to have worked out. So maybe this operation is distributive. However, maybe it's not. Note that A is an element that makes everything into an A when you use the star. And since A is starred with something on this side, and A is starred with everything on this side, that we're just going to, we have to get A equals A. A wasn't, okay, this wasn't a particularly good choice of three elements to check. Let's just do one other check just to see if we can get a better indication. Let's try something that doesn't involve an A. Let's try B star C dot E and see if that's equal to B star C dot B star E. Make those dots look a little bigger. Okay, let's see. That E doesn't look much like an E. Let's make sure we've got that right. Okay, so C dot E. C dot E gives us B. So we end up with B star B. Now is that equal to B star C? Okay, now B star C is C dot B star E. B star E is E. B star B gives us C, And C star E gives us, gives us D. I'm sorry, it should be C dot E, which gives us B. C dot E gives us B, not D. We'll change that into a B with the magic of whiteout. So even though it might have appeared after the first check that this operation is distributive, one more check where we don't use the A element shows us that it's not. Now there might be other cases that do give you an identity here, even cases that don't involve the A element, but in general we cannot say that this is a distributive operation. Sometimes it might act distributive, but it's not distributive. It's not always distributive, so it does not have the distributive property, or this pair of operations does not have the distributive property. And we would say then that the star operation does not distribute over the dot operation. Now it's possible that the dot operation might distribute over the star operation. You could check that out if you like, and it should be fairly obvious how to do that.